Welcome to Food Technology 1, FOT 150S. I am Vosim Shaisa, and today we're going to be talking about food product formulations and food process flow diagrams. So this is an introduction, and we will aim to highlight the basic components of a food product formulation and a process flow diagram. So we welcome all those that are joining us. Standiwe Dlamini, we see you. Vusmozi Boy, you are also there. Apiwe Mvambi, Bokoma Emmanuel, Zakaria, Asive Njongo, Nasipi, and so on and so forth. So I aim to make this as short as possible, and this is very key in the food project that you will be involved in. So some of these components will find much application in the food project that you are doing. So without further ado, let's look at the content of this presentation. So we will start with an introduction and recap on mini assignment 1 and 2, and we will also look at what are product formulations and why are these important. We will also look at process flow diagrams, and we'll also look at the conclusions. Just a reminder that in the mini assignment 1, you were tasked to design or draw a simple process flow diagram detailing all the steps of your given products. Some people worked on wine. Some people worked on full cream strawberry yogurt. Some people worked on the manufacturer of a Dijon mustard. Some people worked on chocolate, and so on and so forth. Then on the mini assignment 2, we tasked you to conduct an in-depth literature search on your given food product, and you were requested to provide a list of ingredients in a table format that can be then used in the manufacture of your given food product. And we further asked you to indicate the quantities using appropriate units. So by appropriate units, we meant using the SI units, kilograms, grams, etc. And then we also said you must then highlight to us what are the roles of each ingredients that are used in your given food product. So let's look at a food process diagram. So during this mini assignment that you had to draw. Some people used Microsoft Word, some people they drew using a pencil and a pen, and then they uploaded their pictures. We define a process flow diagram as a logical basic sequence of steps to produce an acceptable and quality food product from raw materials. So as I've mentioned in class, when we began with the course, we said food technology entails converting raw materials using food processing operations into giving us a final product. And the examples that we've also made, like for example, taking an apple from a tree and subjecting it through a certain process, then you end up with an apple juice. In order for you then to do that, this raw material that you have needs to undergo through a series of steps. Most of you did well on this exercise in the mini assignment 1 and 2, because the aim was to introduce you to the food processing industry and the various units that are used in converting or processing food products. If we look at this process flow diagram as shown or as depicted here, we see that there is a starting step, which is a raw material. Then this raw material is washed. It goes through sorting and grading operations. So sorting and grading will be our next chapter, after the cleaning of the raw materials, then it goes through blanching. We've already spoke about blanching during class, and we've conducted some experiments or practicals on the blanching operations. Then this will go through a preparatory step where it goes through peeling, slicing, filling, exhausting, sealing, thermal processing. So there's heat that is applied at this step, then it's cooled, labeling, and storage. While this flow diagram can give us an indication on how this raw material is processed, it presents some challenges or disadvantages for us. One, it does not tell us what raw material is being processed here. Number two, it does not tell us how much of that raw material is used. So in other words, there is no quantity that is specified. We don't know whether they are using only one orange or they are only using 10 orange or 10 bags of oranges, right? And it does not tell us what are some of the major processes that we need to control. For example, you and I know that based on the experiments that we have conducted in the pilot plant, that various fruits and vegetables require various blanching times. So if we look at this blanching step, we are then not told how long is the blanching. Right. So from this we see that there are some challenges that we need to overcome in terms of coming up with a new food product that will go into market. So when we develop food products, they go through, as I've said, normally at home you would have a recipe that you have, and that recipe will tell you add how much water, add how much flour, add how much salt. In this case, in this flow diagram, it does not provide us with that information. And this flow diagram assumes that all these raw materials, they go through the same process. It may not necessarily be the case. So the aim of this presentation is to assist us into coming up with a way that we can use in a simple format that will enable us to go to the pilot plant to produce a food product, knowing what is it that we need to add, how much of the ingredient we need to add, and where in the process we need to add that particular ingredient. So by the end of this presentation, then you should know what is a food product formulation and what is a necessary food product flow diagram that you should apply in your project, which is the ginger beer, during the manufacturing in the pilot plant. And this will greatly assist you in the successful completion of your project.
They're asking us, what is a product formulation? Well, a product formulation is a combination of raw materials in specific proportions that are used to manufacture a safe, nutritious, and wholesome food product. So if we would look at a product formulation for a Kasegriller is a type of a sausage that contains cheese. So if I look at the left here, you'd have in your ingredients lean beef, which is 90:10 ratio, lean pork, fatty pork, it has cheese. They also use ice and the complete pack. So the complete pack will be the spices that goes in there. So then you would go into the lab and you do some experiments to see how much of each do you need. So this person has conducted some experiments and they want to add 2.5 kilograms of that and 2.5 kilograms of that, 7.5 kilograms of fatty pork, and 1.5 kilograms of cheese. And then there is ice, and there's the spice pack is 0.6. So if you would sum up all these quantities, then you'd end up at 17.1 kilogram. So the 17.1 kilogram, we therefore call it a batch size. So this is a total batch that you have. So if you then take in these quantities that you have, all of them, they're expressed in kilograms, and you want to express now in percentage. So that would mean 2.5 divided by 17.1 multiplied by 100, that will give you 14.62. And so this is also the same because it's 2.5. And if you sum up everything here, it will lead you to 100%. So this then is called a product formulation. So before the person can go into the lab or into the pilot plant to manufacture a product, at least he or she already knows what are the quantities that he needs in order to perform or to produce this Kasegriller, which is this product. It's a sausage with cheese, right, as you can see here at the bottom. Perhaps now, Apiwe Mvambi, you are asking yourself, the question is, but say, how can one do this in practice? Well, let us say you are given a percentage. Now that you know the percentage of each ingredient that goes into your process, right? So if you know each ingredient that goes into a process, you can then use any batch size. You can be able to manufacture any batch size. How do you do that? You simply say 14.62 divided by the total, which is 100. And let's say in this case, we want to manufacture 250 kilograms divided by 250. So that means you need 36.55 of this ingredient, and same here. And you need 109.65 kilograms for fatty pork, and for your spice pack will be 8.775. And if you sum up all these values, they will give you a 250 kilogram. So that means for this particular batch size, we have 250, which is the total product that you will produce. Please note that in this previous example, the batch size was 17.1. If we want to upscale that 17.1 to 250, the quantities here will change. However, the percentage remains the same. So if you look here, the percentage remains the same, the quantity has changed. So here is a formulation that I've done at home while I was baking some nice biscuits. And by the way, indeed, in Ntabiseng, I bake during my spare time, and this is one of the products that I've tried to manufacture when I was playing along. Maybe, Zach, we can come up with a business proposal to do this. So we are looking at biscuits here. This is a product formulation. So this then tells me what is the quantity of ingredients that I need to manufacture my product. So the type of ingredients that I have milk, castor sugar, flour, salted butter, and cocoa powder. And these are the proportions in percentage that I need. Note again, all these will sum up to 100. But now in the lab or in the pilot plant, you need to be able to convert your percentage into a known quantity that you can be able to measure, right? So then I would then say 9.89 divided by 100, that will give you 24.7. So I need 24.7 kilograms of milk, caster sugar 48, and flour 121, and that 35. So all these will sum up to a batch size of 250 kilograms. So now that I have the formulation sorted out, I am ready to go to the lab. There is a further step that I need. So then you're asking yourself, how does this fit, say, into a food process flow diagram? So the next step is, this is how it fits. So then I would have a biscuit process flow diagram. So if you remember my ingredients, I had milk, caster sugar, flour, satchel butter, cocoa powder, and now I have an introduction, which is a new component, which is packaging. Because remember, you are going to be in the food industry and you are not going to produce food products and then you just leave it there. So you're going to pack your products. So now I go to the pilot plant. So these are my ingredients. The first step that you need to do is to weigh in your ingredients. So the W stands for weighing, which you will weigh the amount that you have calculated from the previous example that I've shown. So that means you need milk 24.73 kilograms, and then you weigh in all your ingredients. So this is your first step. Note, packaging does not have a weighing, so you don't weigh packaging, right? Because you're going to package the material there. So what is the first step? The first step, I need to mix all these. So this will be my mixing step. All these ingredients that I have, mix them to form a dough. Once my dough is formed, then I will mold my dough into shapes, right, to give me a certain shape, either a round shape or a rectangular shape, whatever that you want in your process. So once you are done with the molding, your dough will go into baking. So baking is a unit operation. So in this case, I need to bake my biscuits at 170 degrees Celsius for 10 minutes. Once the time had elapsed, then I would need to cool my biscuits from this temperature to here, from 170 to 20 degrees. Then at least once my biscuits are at 20 degrees, I can then package and label them. So then packaging comes in here. So packaging, we are using it at this stage. Then after you've packaged and then maybe labeled, so the labeling would be, for example, putting in a barcode or putting in a product label to your product, or in some cases putting a best before date. So that part forms part of the labeling stage. And then once we are done with that, so the product is ready, you can then ship it for storage and distribution. So storage, you can store it in your facility, or you can then store it in a distribution center, which will then go to the consumer. So the beautiful thing about this type of a flow diagram is that anybody can then use this, can follow this process if they have the product formulation and the necessary equipment required to process or to produce this product. So what you need to understand, what you need to see the differences from the initial process flow diagrams that we have done is that here you are clear in terms of where each ingredient goes and how much of each ingredient is going to be used at which stage. Right, let's look at okay, before we go there, what I've done here, I've put in a key for you. So if you can see, all my ingredients are colored in green, and then the processing stages, which are the conversion of your raw material, so I've colored that in blue, and the packaging is orange, and then the storage and distribution is of a different color. So I've just added the key for you in all these flow diagrams that you're going to see, but for you, you do not necessarily have to add the key, but it's a good thing to have it there, but I will not really think it's a requirement as long as you can indicate clearly your processing steps. So you can see there's a clear logical sequence of flow of material, right? So let us look at a what we call a state yogurt. So again, you would have a known product formulation. In this case, we have starter cultures, pre-treated milk. Pre-treated milk is milk, for example, that has been homogenized and pasteurized. And then we would have a flavoring premix. So in this case, this flavoring premix contains sugar, whole fruit, stabilizers, color, and some flavoring components like vanilla essence. So if we start here, you start with your starter culture and your pre-treated milk. So you weigh in your milk and you weigh in your starter culture. So a starter culture is used in order to inoculate the milk. So we call this an inoculation step. So once you are done with the inoculation, then they go through a process of fermentation. So the fermentation would either be from 42 degrees Celsius at pH 4.5 and maybe for 24 hours, depending on the time that you would like to have. So what is more important to understand, we'll see it when we cover the section on fermentation. Temperature is important, and the pH, and also the processing time. So once the fermentation period has done, then you need to cool in your product to at least 7 degrees. Then you can then add in the flavorings, right? So you can then add in the flavoring at the last stage. Perhaps you're asking yourself, why don't we perhaps add the flavorings at the inoculation stage? It is because in some cases you may find that some of the flavorings, they are not heat stable above, let's say, 30 degrees. Then the flavors will start to be degraded. So we add the flavors at the last part. Then once the flavorings are added, then you would need in your packaging to come through. So you package your yogurt, and then it will be ready for storage and distribution. So depending on the type of packaging that you have, you may also do labeling, best before date, etc., etc. So if you look at the key also that I have here, my raw materials are this color, processing blue, packaging green, storage and distribution. So you can see there's a logical flow of information, right, of the processing steps. So I hope, Netai, you are still following, or you are still with us. So let's look at the last example. So the last example I have is the processing of process flow diagram for beer. Oh, I can see some people, they are already laughing. Pride, is this your favorite beverage? No, I'm joking. So what we have here is the ingredients that we are using. It's water, yeast, barley, hops, flavor and spices, and then we have the packaging. And when you manufacture this, obviously, as I've said, we've seen through the previous examples, we need to weigh in our ingredients. So for example, the first step will be the malting. So the malting is only the barley that is malted. And then after this step, we then add in water in the milling step. So you add in water, and then from there it goes through a mashing stage. So you'll read up on beer, the different mashing temperatures, mashing processing times that you can then use. Then from there it goes through a boiling, so boiling at 100 degrees. So when you're boiling, then you add in what we call in your hops. They come in here. And from there we go to the process of fermentation or fermenting the beer. This is where you add in your yeast, and then again here processing temperature, processing time, and pH is important. So in this case you can also add in flavorings and spices. So from there you have filtering. So you filter in the yeast, then your beer goes for a packaging. So this is where your packaging comes in. Your packaging can either be in bottles or in cans. Then it goes through a storage process. And you can also see at the side, I've also added a key here. So what is also important to note, perhaps Ashere, you are asking the question, but say on the previous slide you said flavorings can be added on the last part, but when it comes to beer we are adding at the fermenting. The answer is yes. So flavorings depends on the type of product that you are producing. In the case of beer, you can add them in the fermentation process because there's also no sugars that are added here. So a process flow diagram is different for each and every product. So what we request from you is that you follow this sequence. Show us your ingredients, show us your weighing steps, then the processing steps that you have, and then packaging and distribution. What we have not yet really delved into here is the type of packaging that one can use, but we know packaging will go at this step. For example, beer can either be packaged in glass bottles, these ones that they call the 750 a gram. I think Jali they call them ingudu, if I'm not mistaken. Sisonke will know that, of course. And then we also have beers that are packaged in cans, like your 6-pack. So packaging, we will cover that in the following sections, but for now you just need to know that your final product needs to be packaged. Packaging needs to be taken into consideration. So what is the conclusion? So product formulation, what is more important is that you need to use the same units. If you are using kilograms, stick to kilograms. Or if you are using grams, stick to the same units, grams. Don't use teaspoons and then use kilograms at the same product formulation. By the way, teaspoons is for recipes that we do at home. Industrially, we work with larger quantities such as kilograms and even up to tons. Right. So your percentage when it comes to your product formulation, it should always equals to 100 for any given batch size. So your batch size should always be up to 100%. So your process flow diagram should also indicate the ingredients. What are the ingredients that you're going to use and where each ingredient is used? It must show us, must exhibit a logical flow so that we can follow the sequence. So again, don't forget your packaging. And more importantly, check the brief on Blackboard on your next mini assignment. Ladies and gentlemen, thank you for listening. Please, if you have any questions or comments, drop me an email or start a discussion on the WhatsApp group. Thank you.